Okay, in this video we're going to look in more detail at a particular kind of thermometer, which is probably the one that you're most familiar with, and that is a liquid in glass thermometer. Alright, there are several important factors you need to consider if you were designing a thermometer like this, or that you should know about if you're using a thermometer like this. So we're going to first look at the basic design of one of these thermometers. So what we have here is basically like the same thermometer 3 times with different temperature scales. That's not so important, but it is useful for you to see the difference. Fahrenheit versus Kelvin versus Celsius. Now they all have, obviously the boiling point of water is a specific temperature, but this shows that if you were to put this same thermometer into boiling water, but you had it marked for different temperature scales, then it shows you what the temperature reading would be for each of those scales at the boiling point of water and at the freezing point of water. All right, so basically Kelvin boils at 373, boiling water on Celsius is 100, and on Fahrenheit it's 212. And then these are the freezing points. Not that important. We will always use Celsius or Kelvin in this course. We want to look at the basic design of these thermometers. First, at the bottom here is the bulb, and that's where you have thin glass there so that it's able to react quickly. There's not as much glass for the heat exchange to occur between this liquid in here and whatever substance you're putting it into to measure its temperature. So basically the temperature of this needs to equalize with the temperature of whatever you're putting it into. So thin glass around that and lots of liquid in the bulb. Through this part here, you've got increments marked at equal distances, and those increments tell you some difference in degrees of temperature, and that's your temperature scale. And then here, this part, this long tube part, actually has a fairly thick glass around it, and the inside that's empty is very, very thin. You can't see it very well here, but it's called a capillary tube because the empty space inside there is actually quite thin, and that allows a relatively small expansion of the liquid to cause the liquid to go a larger distance up the tube, because the only place for this to expand is up the tube into the empty space of the capillary. The less empty space there is in the capillary, then the further the liquid has to go up the tube in order to expand. So anyway, that's one of the ways that you can mess with the design. Okay, factors that we need to consider. There are 3 of them. The first one is called linearity, and basically that is whether the liquid expands at a constant rate or a linear fashion. All right, so the same temperature change should always produce the same amount of expansion. So what do we mean by that? Basically, these have to be all the same size increments, and you have to choose your liquid that you put into the tube based on whether it is linear over the range that you're interested in, which is the next thing we'll talk about. So basically, if you were to plot the expansion versus the temperature, so say this is expansion on the y-axis and this is temperature, so maybe we'd call this expansion, and this is temp, then you would you'd want this to be a linear graph. All right. If it's not linear, it's a bad material to be using for your thermometer. Okay. You want all of these increments to be equal. That's basically linearity. Okay, range. So this is basically the range of temperatures that you can accurately measure with your chosen liquid substance. All right. It has to remain a liquid over the desired range of temperatures. Typically, laboratory thermometers use organic liquids that boil above 100 degrees Celsius and they freeze below 0 degrees Celsius, so that you can use those thermometers over all of the typical range of temperatures that you would need in a laboratory. All right. So usually those are organic liquids like kerosene, for example, or sometimes if it's for a really low temperature, they might use pentane or something like that. But anyway, or even alcohol. But alcohol boils below 100 degrees, so it's not great for trying to measure boiling water, for example. Sometimes mercury is used also. Basically, the range it's really simple. It's how far you can measure. So here, this thermometer has a range only up to 40 degrees Celsius. So you wouldn't want to put that in boiling water. Okay? Let me zoom in on this one. This is an old style clinical thermometer, and you'll notice it only goes from 35 degrees Celsius up to 42 degrees Celsius. This is meant to measure body temperature only, right? That's a very small range, but it's a very specific purpose, and that's for measuring body temperature. All right, and then this is a typical laboratory thermometer, and you can see that it goes from minus 15 or so up to more than 100, 110, it looks like up at the top there. All right, so that's the idea of range. You have to pick your thermometer based on the range of temperatures that you're going to measure. All right, last thing we want to talk about in this video, sensitivity. And this basically is the concept of how far does the liquid expand in a certain temperature change. So if we want to measure very small temperature changes, we need high sensitivity. And if range is more important than sensitivity, then we can have a low sensitivity, and then we'll be able to cover a larger range probably. Anyway, if you want high sensitivity and a large range, you'd need a really long thermometer. All right, and you'll understand that in a minute. All right, so how can we make a thermometer more sensitive? Well, basically we can change its design. For example, we can make the capillary tube narrower, and that would mean that the same expansion of liquid has to cover a larger distance because there's less space available in the tube. So it has to expand by a certain volume. If you make the tube narrower, the same volume of expansion causes a larger distance of movement. All right, and we'll look at that, well, on the next slide. I've got some pictures to go with this. All right, the second option is you could change the substance that you put into the thermometer. Maybe a different substance is going to expand more than some other substance. So if you can find a liquid that expands more than some other liquid, that would be a better choice if you want high sensitivity. Okay, so basically you can change the design of the thermometer so that the liquid moves further, same liquid moves further for the same temperature change, or you can change to a different liquid that moves further on its own. It just expands more as a property of that liquid. All right, and here's a visual to go along with the idea of sensitivity. Okay, so basically what we have is an original thermometer, right? An initial state of a thermometer, and then we have, let's just say this is one where we've changed the internal design so that it expands more for the same temp, and this is the same substance in each of them. All right, so this is the initial thermometer, the original state of it, and that's the reading before we change the temperature. And then what we've got is a low sensitivity thermometer and a high sensitivity thermometer, and this is after we change the temperature here. Then we want to see what happens to the thermometers. And the low sensitivity thermometer, you'll notice not much change, right? A small change for 1 degree Celsius, which is what we're saying happens here, just as a schematic diagram version. But a high sensitivity thermometer, here's the difference. Same temperature change, right? But much larger linear expansion, or much larger distance moved. It's the same expansion because this is the same liquid we're saying. All right, we're saying it's the same liquid, but we've changed the design of this thermometer so that the same expansion, the same amount of expansion causes a larger movement of the liquid, narrower tube. So the tube here is narrower, more narrow than this one. More narrow here, less narrow here. It's wider inside there and it's narrower inside here. So the same temperature change causes a much larger linear distance covered. All right, a much larger distance covered. So basically, there's a visual to go along with sensitivity. This is a high sensitivity. This is low sensitivity because it doesn't change as much. This one changes more. Okay, that's all I've got for you in this video. Thanks for watching.